Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at the University of Albany and Joel. We're here, some brothers here, trying to help you approach SAT math questions, if not all math questions or a lot of math questions. I just worked with a person. A person gave me some comments about our videos, and I just wanted to share them with Seth live, and then we'll move on. He said that sometimes you skip the easier, faster way to do the problem, and you do more questions more complicated. So, this is what I think. So maybe what we should start doing is every time we look at a problem, we should invest. No, this is what you should do when you take the test. You should invest maybe 5 or 6, maybe 10, no more than 10 seconds, asking yourself, is there a really fast way to do this problem that just cuts through everything, that takes advantage of the patterns? And that's not a bad way to approach SAT math questions, because if there is, then investing up to 10 seconds and then blasting through it is really a good way to do it. So that, as Seth said, you bank time. So, what do you think, Seth? You think we should always ask ourselves before we dive right into it whether there's a faster way to do it? That's maybe uses.
Oh, yeah.
Yes. Yeah. Okay.
In other words, well, there are two. I can think of two variants of a faster way of doing it. One is based on the structure of the problem, the kind of problem it is, and the second is detecting a coincidence or pattern.
Right.
In other words, that the problem has special structure that not all problems like it have, and which you could take advantage of.
Right.
For example, this problem.
Yeah. Right. Yeah. For example, this problem. Right. Okay. So let's start with this. This is from Khan Academy, and we've run out of SAT math questions because we don't want to do actual tests. So now we strongly encourage you to go through Khan Academy and practice, because they tell you exactly what's on the test. So let's go. Why don't you try this problem, and then we will try it. Please try it, pause it, come back, and we will do it in our new way. We will ask ourselves, before we do the problem in a more traditional way, we will ask ourselves, is there a way that you can do this problem in really fast time? And something tells me there is. Something tells me there is.
Okay, well, I'll be right. Okay, we get a.
See, the thing is, x can't be negative. X can't be -3.
Oh, that's a good point.
You can't have x being -3. So goodbye. Now, let's move that 3 over here. If it's x minus 3, we're subtracting the 3 here. X minus 3. Oh my God, you can't have a negative number. You can't have -5. You can't have -5 minus 3 to be -8. Goodbye has to be the answer. Whoa, that kid was right. Maybe it does make sense to invest 10 seconds to think about whether there's a really fast way to do this, as opposed to the traditional way where you have to show where you work and get the answer.
Oh yeah, that was great.
School.
Yeah.
There's this disconnect then between doing the problems the way you do them in school and doing the problems the optimal way to do them on the SAT.
Yeah.
Interesting
Good
point, right? Did you have to be careful about what you're studying? So
yeah, good, wow. Very good. Yeah. And yeah. So now this problem actually, several other observations could be made that lead you to the same information. For example, if x were negative, then the square root would be of a negative quantity.
I know, we just said that.
Well. You said.
Oh, you mean even this one's out?
Yeah, you said x. You calculated x minus 3, and you said that couldn't be negative because on the SAT, square root symbol means positive square root. But then I looked inside the square root and saw that when x is negative, the quantity inside the square root symbol is negative.
Oh my goodness, I totally didn't notice. Oh, let me undo a lot
So
of
we
stuff.
different people, and
Oh,
you might notice several different coincidences. Now
yeah.
there is a another coincidence, which actually I noticed first, but the one that Joel found leads to the solution even quicker.
Hmm.
The coincidence I found, and could you write this for me because my annotator doesn't seem to be working.
Okay,
Look
okay.
at the 6 and the 2,
Got it. Yeah.
and somewhere underneath the 6 and the 2, write a 3 and a 1.
Well, should I just factor that out?
No,
Okay. Minus
write a
6.
3 and a 1,
Should I put a
and
negative 3?
yeah. So notice that if you were to subtract the 3 from both sides, of the original equation, which is what you did, right?
Right?
So when you wrote x minus 3, how about this? Right to the left of it. No,
Yep.
no. On
Yep.
the where you wrote x minus
Yeah.
3 in the middle of
Yeah.
right there to the left of the x minus 3, right, equals square root of minus 6 plus 2.
Right. 2x.
2x, yes, yes. And so and then so yeah, you could factor out a square root of 2 from the left hand side.
Okay. Yeah. I
That's
can
a
factor out.
coincidence. Yeah.
Yeah, but how does that help you?
Well, it doesn't help that much, but this also indicates the two things we notice: that x cannot be negative, right?
Right.
Yeah.
Yeah.
Well, actually, yeah, because in the SAT, square root symbols mean positive square root.
No, but that's not why x can't be negative. X can't be negative. No, that's not why x can't be
Oh,
negative
you're right. There are
because
two reasons. There are two reasons.
no, x can't be negative
One is a
because
good reason, the other is a bad reason.
yeah,
The good reason is that when you take you can't take the square root of a negative number if we're doing real
that's
in
right.
the real
That's
number
the answer.
system.
Right, 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 right.
But if you went to the complex numbers, you could take a square root of a negative
That's
number,
right.
but the result is imaginary,
That's right. That's right.
and you're interested in a real solution to the problem,
Right. That's right.
right? So x minus 3, yeah,
Yeah, yeah, yeah,
can
yeah,
be,
yeah, 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 yeah,
yeah.
yeah. Yeah. And but Seth, you're right. You're right. You're right. If this well, okay, if this was a 5, well, x can't be negative. Period. Just x can't be negative because this makes the thing negative, right? Negative 6 plus 2x is
Yeah.
less than 0 if x is less than 0, period. And
Yeah.
that
Okay.
that does
Good.
it. That
Yeah.
just
Well, I
that's
think they
the
were very careful.
that just does it.
They were noticing this problem. Now let's go a little bit deeper.
Yep.
Let's go to deeper math. They did not ask for all of the solutions.
Okay. Yeah, right.
They simply gave you two proposed solutions in each response, and your job is to judge for which of the responses are the two proposed numbers actually solutions.
Right. Right.
So they omitted the question. They posed the essay. They wrote the challenge in a way that avoids the question of whether there are complex valued solutions.
Right. 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 Now,
So maybe there's a complex valued solution.
well, okay, so I think we should do two more things before we bid goodbye to everyone. One, we should solve it the traditional way, which is where a teacher, let's say on a test, someone would say, okay, do the problem, show will work. We should do that. And second, I am dying to look at how they did it. I just can't wait to see how they presented the solution. Did they do it the way we did it, or did they do it the normal traditional way? Although, frankly, so far as an SAT, we should consider the way we did it a normal traditional way, because this is probably the way one should approach a problem like this on the SAT, because it's so fast. So anyway, how do you do this traditionally? You subtract the 3 on both sides, and you get this thing right here. Okay, you get the square root of negative 6 plus 2x is equal to x minus 3. You square both sides, so you get minus x plus 2x. Now, every time you square both sides, you have to expect extraneous solutions. X squared minus 6x plus 9. Mm-hmm. Now, we got to be really careful here. We have to add a 6 to both sides, because we have to set this to 0. We have to subtract a 2x on both sides, and we get a quadratic, which is completely expected, because we have two answers. Minus 2x plus 15. Does that make sense? And now we see 5 and 3 are going to be the roots. We now have to factor a quadratic, which is skills you are going to have to know how to do for the SAT. So you factor this thing. You say 0 is x minus, this is what two numbers multiplied at 15 but add to minus 8, negative 3 and negative 5. Every time you factor, you should double check your factoring. X squared minus 5x minus 3x makes minus 8x plus 15. This is correct. Their answers are 3 and 5. And then you check. If you, on a normal test, you would check to make sure that the answers really are 3 and 5. Because anytime you square both sides of an equation, you get what's known as extraneous roots. Yeah. And you're not done with the problem until you actually check. But in this case, you don't check because those are the answers. It's pretty, yeah, you don't have to sit there and check with 3 and 5 of the answers because they're telling you 3 and 5 of the answers. There's no other choice. So, okay. So, I mean, any problem with the way I did this? No. So, ready? Drum roll. Let's see how they did it. What do you think? What do you think, Seth? Do you think they did it this way, the normal, traditional way, show will work? Or do you think they said, hey, just get rid of all the negative answers because X can't be negative? What do you think? What's your guess?
I think they did it the traditional way. Simplify and
I think you're right also. So let's annotate.
We'll see.
Clear all drawings and clear this so that I have access to screen control. Oh, first of all, let's do it. Look at us. We got the right answer. Okay.
We got an answer that our answer agrees with.
Right.
Our answer agrees with the answer they gave. So it's possible both of us are wrong.
It's possible. Okay.
But we are pretty sure we're right, and so we're sure that they are right.
Oh my goodness! Oh my goodness! Oh my goodness! You were right, Seth. And I sort of had the same idea. They're doing it the normal way, where the show and go will work. Ouch! Yeah. Did they even give you a way? Did they even give you a choice? Did they even at the end, like we try to do, is give alternate ways to do the problem? Wow! Look at this. Oh, look at this. So they are using extraneous solutions. They're saying, oh, you have to check. Because they know that when you square both sides, you have to use extraneous solutions. You have to test for extraneous solutions. Wow. Yeah. My goodness. Now, don't forget, these are not technically the SAT people. These are people sanctioned by the SAT people. This is Khan Academy. And I think the purpose of these questions is to show how to do the problems. Although, again, this is not exactly SAT questions, but they're sanctioned by. Wow. So that's pretty, they should have said, hey, there was another way to do this. Wow. So then, I don't know what to say in terms of, looking at the problem, thinking about other ways to do it yourself, which on Khan, they're not going to give those to you in the answers. But we're planning on going through every Khan question, so if you have the patience to listen to us for 400 days, we promise that we will offer alternate, faster ways to do the problems. That's our promise to you. So, Seth, looks like you're doing some heavy-duty calculation there. Seth, what are you doing? Seth?
Well, what I did was
Can't wait to hear.
I can't write it. I can't. So could you scribble this?
Of course. Go ahead. Sure.
I got an equivalent equation.
Yeah.
Uh, the square root of 2.
Oh wow, Seth's really into this
Yeah.
doing all this algebraic
Uh,
manipulation. I can't
Can
wait
you
to
write it
see.
down?
I'm
I
trying
can't
to, but I
write.
gotta set up my annotation first. Square root of 2, yeah.
Write a square root of 2.
Yep.
And then multiply that by the square root of x minus 3.
No, it's negative x. Oh yeah, x minus 3, right? Yeah.
Yes.
Okay.
And that equals x minus 3.
Okay. Cool.
Right?
Yeah.
And then at that point, one could square both sides.
Sure. So you get 2x minus 3. Oh my goodness. Whoa, Seth. What is Seth trying to do? But
Yeah.
you can't divide by
So
x
one
minus
solution
3.
is x minus 3 equals 0.
One solution is x minus 3 is equal to 0, right?
Right? And the other solution is x minus 3 is 2.
Oh, because this is 2 little person is equal to little person squared. So little
Yeah,
person
yeah,
is equal to
that's right.
what? Little person is equal to 2. Oh, yeah, little person is equal to 2.
Yeah.
So if little person is equal to 2, if that's equal to x minus 3, then x equals 5. Wow. Wow, that's a cute way of solving that problem, noticing that there's a pattern x minus 3 and x minus 3.
Yeah, that's what noticing the pattern of x minus 3 and 2 times x minus 3 can be used.
Right. The question is time wise, how long did it take you to see that, as opposed to how long does it take just to do it the normal traditional
Yeah,
way, which is
I think what went through my mind when we did this together was several. We saw at least 3 approaches, all 3 of which are pretty efficient.
You mean even including the normal way?
Yeah, that's not so bad.
It's not that bad. Yeah, if you're fast with multiplying
But the other
quadratics.
way, no, I think we saw at least about 3 ways of 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 looking at the maybe 2 ways of looking at the general structure of the problem, and then 1 way of observing. I think maybe there were 2 ways of looking at the general structure of the problem, and 2 ways of using the fact that there's an expression x minus 3 on one side of the equation and an expression twice of x minus 3 on the other side.
Right. Yeah. Yeah. Yeah.
Yeah.
Yeah. Okay. Yeah. Some people, everyone makes this mistake, including me. I've made it once or twice. Well, hopefully only once. When you have an equation that looks like this, do not divide both sides by x minus 3 and just say I'm done. Okay, because if you're doing that, if x minus 3 equals 0, then you're dividing an equation by 0, and you cannot do that. Spam. Why can't you divide an equation by 0? You can't you can't multiply an equation by 0. What about 7 is equal to 4? That is not true. But let's multiply both sides by 0. You get 0 equals 0. That's true. You can't multiply or divide both sides in an equation by 0. So
So the truth is, you could multiply both sides of an equation by 0 and when you multiply both sides of an equation by 0, you get a true equation. However, you can multiply both sides of an equation by 0.
Of course you can.
And with a meaningful result. The problem is that the meaningful result is useless for finding solutions to the equation.
Okay. Yeah.
Because when the equation is multiplied by 0, you get an equation that has many, many more solutions to the original equation.
Hmm.
And so it gives you no information about what the solutions of the original equation are.
Aha. Got it. Yeah.
Now, about dividing both sides by zero, uh, uh, take a false equation.
Okay. 70s. Oh. 3 is equal to 5.
Yeah, 3 is equal, and now divide both sides by zero.
Okay. Divide both sides by 0. Yeah.
And whatever you get, well, you for on one hand, you do not get meaningful numbers on the two sides,
Right. Yeah.
right? Uh, you cannot get a number which, when multiplied by zero, equals 3,
Right. Yeah. Yeah.
right?
Right. Right.
Now, suppose you said, well, okay, here we go. So, let's make up a new rule and say that when you divide a uh, a non-zero number by zero, you get what's called infinity.
Okay. Uh,
So
7 divided by 0 is infinity, sort of. Sort of.
yeah, well, it's 5 divided by zero.
It's also infinity.
So from a false equation, you got yourself infinity equals infinity.
Yeah.
So the general principle that when you do the same thing to both sides of a true equation, the result is a true equation. That principle is it doesn't hold here. It's false. Okay.
I didn't quite understand that, but
Well, what you got a false statement followed by a false assumption. Well, no, a false statement. Yeah. Well, from a false statement, you could always prove a true statement. From a false statement, you can prove anything.
Yeah.
Yeah.
Okay. Okay. So just don't make this mistake. This is very insidious. How is it insidious? You may see something like 3x squared is equal to x.
Yeah.
Okay, you may see something like this, and you let your guard down. Say, oh, I'll just divide by x. 3x is equal to
now.
No.
So let's look at that. Let's talk a little bit more about that equation that you just circled. Here is something that is logical. Here's what you could do. You could ask yourself, what values of x will satisfy the equation?
Right.
And you look for values of x that satisfy the equation.
Right.
One possibility is an x such that x minus 3 is 0.
Right. Yeah. Right. That's right.
And that x does satisfy the equation.
Absolutely. Absolutely.
Now, consider what you could calculate about an x that is not equal to 3.
Yeah, you can divide both sides of the equation.
Yes. So if you restrict x to be a number that's not equal to 3,
yeah, let's do it.
You can divide both sides of the equation by x minus 3.
Yeah, that's right.
And it will lead you to an equation that is true for x's that satisfy the first equation.
Right.
It will be a non-trivial equation, so it will tell you what x's that satisfy the equation can be.
That's right. So this would be an alternate way to solve the thing that you did very quickly when you
Yeah.
said, "Oh, x is equal to 3 and x is equal to 5." Yeah, when we do the little man, right? 2 times the 2. Yeah. So yeah, so this is the other way, right? So yeah, so you
Yeah.
absolutely can do that. Yeah, wow. So there's a lot of ways to do these problems. These are very rich problems with a lot of alternate solutions. But I'm really surprised and disappointed that Khan Academy didn't mention, hey, there's a real faster way to do this. And yeah, and I must thank the person who texted me this morning with the suggestion that, hey, you guys, Seth and Joel, you really should look for real fast ways to do the problem, because that's how some people do the SAT questions, and that's a good way to approach the SAT questions. To first invest a few seconds to say, hey, can I just figure something? Can I just use my brain rather than my pencil to do this problem in blitzingly fast speed?
Yeah.
Okay, well, we are done, man. 25 minutes on this one. Whatever.
Yeah.
So, hopefully, we gave you some approaches, some insights, and just keep practicing. Go to Con and keep practicing. Okay, everyone, have a great day. Bye bye.
Hmm.